Do you realize that when you're driving on gasoline, do you know that you're running on a hydrogen? You know that if you look at the chemical equation of gasoline, you will find out the hydrogen atom is attached to the carbon atom. Is not so? And basically, in the highest octane of gasoline, you have roughly about a half a pound of hydrogen to it. Now, water, on the other hand, is 2 to 1. 2 hydrogen atoms to 1 oxygen atom. Is it not so? How many pounds of hydrogen do we have in water? You find out by the atomic weight it's around 1.7 pounds of hydrogen in water. I had the most scientific compilation study on hydrogen that's ever come out of the scientific world from NASA. Did we not propel the Columbia spaceship by hydrogen and oxygen? And in that report it clearly stipulated that hydrogen was the most ideal fuel of the future. It can be utilized anywhere, solve even the environmental pollution problem, but they did not have an answer in 3 areas. 1, to produce the hydrogen gas or release it economically from water, control the rate of production, be able to adjust the burn rate of hydrogen gas to co-equal to fossil fuels, and add the 4th one, be able to transport it without spark ignition. And I wrote all the patent rights both nationally and internationally on this type of technology, to be able to use water as a fuel source. Go ahead. Now, in order to solve the problem as a scientist, you got to learn to ask the right question. This particular quest was, how in the world can you switch off the covalent bonding of the water molecule and do it economically? You know, Einstein said even that there was enough energy in a gallon of water that if you knew how to release it, it could take the power of a 1,000-car train around the earth many, many, many times. Now, when you do your research and development work, don't go back and try to reinvent the same thing that's been being reinvented over and over and over again. To solve a problem, an energy problem, you must go in a different direction. And in this direction, we had to find a way to simply switch off the covalent bonding of the water molecule and not process the water molecule in any way. In order to understand this, then, we went back, and the Lord was showing me, he said, okay, what happens in the law of physics? That for every action, there's an equal and opposite reaction, right? Okay, so when the unlike atoms of the hydrogen atoms covalently link up to the oxygen, normally the oxygen atom has 8 protons and 8 electrons, does it not? But when the oxygen atom now accepts the negative charge electron of the hydrogen atom, now what happens? There's an electrical imbalance that occurs because you still have 8 protons, but you now have a total of 10 electrons, do you not? And under the law of physics says that the first orbit will, the L orbit or K orbit, can maintain up to 2 electrons, isn't that so? But in the next orbit, the L orbit, says to reach stable state to form the water molecule, you can have up to 8 electrons, isn't that so? Now after 8 electrons is now accepted in the L orbit, now the water molecule goes into stable state. But since the hydrogen atom now is sharing its negative charged electron, then the positive charged proton swings the hydrogen atom to a positive electrical charge. Now, when this negative electrical charge is now formed, that negative charge is now formed equivalent to the 2 shared negative electrons, isn't that so? That under the law of physics, that for every action there's a equal and opposite reaction. As a result, now we're setting up an opposite electrical charge, Q and Q prime. Now the next question is asked, is there an electromagnetic field that exists between the oxygen and the hydrogen atom? And the answer is no. For you see, when the oxygen atom accepts the negative charge electron of the hydrogen atom, these electrons pair together, and as a result, cancels out the electromagnetic field, and the oxygen atom does not take on an electromagnetic charge. Oh boy, Lord, this is getting good. And it became very obvious then that all I had to do was go opposite to the electrolysis process. Shut off the flow of amps and expose the water molecule to a high pulse voltage field. Go ahead. Now we know under Coulomb's law of electrical force and under Newton's second law of electrical force, does not voltage perform work? It is not unknown in physics that voltage absolutely performs work. Is that not the same some basis of electronic circuit design? Under Coulomb's law and Newton's second law of electrical force and electronic circuit, would not the positive voltage of this voltage field, if you restrict amps, would it not attract the negative charged electron? Have you ever heard in physics that opposite charges will what? Attract, right? How about like charges? Would not now the negative voltage field here repel that negative charged electron? Absolutely. You know, when we went into the patent office, under 35 U.S. Code 101, showed it to the examiner chief, the experts in physics, chemistry, and electronics, and they realized it was a cold process. They asked the infamous question, why in the world did no one ever think about this? I said, well, you want me to give you an answer? I said, number one, I said, the knowledge of water will come out of time in great trouble. But the reason why Faraday did not discover the electrical polarization process, you see, he needed modern day inventions. He needed the modern day invention of stainless steel 304 material, which forms the voltage zones, which is chemically inert to the process. It does not chemically react to liberated hydrogen and oxygen atoms. You see, he didn't have stainless steel back in those days. The second thing he didn't have the prior knowledge that the water molecule takes on opposite electrical charges. And he didn't have modern electronic circuit design to restrict amps and allow voltage to take over in a dead short condition. He worked with a very crude battery. When he put the electrolyte into the water, it created a dead short condition, and amp flow resolved, and there was no way to restrict the amps because it was dead short. It was a dead short condition. So you see, when you look at modern day inventions, look and see the technology, how and why you can use that advancement of technology for the betterment of mankind.